So I want to compare the fractions 3/4 and 2/3. So I'm going to draw some square cakes to represent them. So that's my best square today, and I'm going to attempt to reproduce that next to it here. That's about right. Okay, to the best of my artistic ability, these two are the same size holes. Not bad. And so for 3/4, I would break that into 4 pieces, and I'm going to do that vertically on this one. So to do that, I think I will cut it in half and then cut those halves in half. And I'll do a little shading. 1, 2. So that's my best picture of 3/4. And I think I get kids with a ruler or a piece of graph paper to draw something pretty similar to that. 3 equal parts of a whole that has 4 equal pieces. 2/3, I'm going to make that one go the other way. So for 2/3, I'm going to try to make my best third. Use my straight line tool to be a little neater. Like a ruler. I'm going to guess that's about 1/3. That's about another 1/3. Not too bad. I'm going to go with it. Let's make believe they're equal. And then I want 2 of those 1/3. Let's do yellow shading. 1, 2. So there's my 2/3 there. Now, as far as comparing them, I can't just compare the numerators and say, well, there's 3 pieces here, so that's got to be more. There's only 2 pieces there. That only uses part of the information I have. So the way to really make it clear about which is which is to just cut each like the other. Which is one reason I drew one vertical and one horizontal. Oops, too many likes there. And I'm just going to make a copy of those and draw that underneath, but you could definitely just draw on top of your own there. I think I have it all. So now I'm going to grab my red ruler here and cut this one in quarters. Best of my artistic ability today. So there's my best quarters on that one. And then this other one I'm going to cut into 1/3. So around there. And kids, hopefully at this point in their life, when they're working with fractions, already have the idea of like multiplication as an area. And so then I can look at the first one and say, well, this is a grid that is 4 on the base and 3 tall. So there's 12 pieces. I've shaded 3 by 3 of them, or 9 of them. And this one here has the same equal 4 by 3, so 12 pieces. And I can see there's a 2 by 4 grid shaded, so that would be 8 of them in the top. And now I can definitely see 9 12s is bigger. And it's not just that it had more pieces initially, because the pieces weren't the same size, so we couldn't directly compare them. So we got to have the same size pieces to compare. So that's a big lesson about this picture here. You need to have the same size pieces to compare fractions. We can kind of guess by looking at the original representation, but it's just a guess. And sometimes I'm going to guess wrong, as hard as I try to guess right, until I cut each like the other. And when we cut each like the other, really what happened there is we just forced a common denominator. So the big idea here is that same size piece is the idea of a common denominator. Now the action that happens mathematically, certainly I have some geometry here, but the cut each like the other idea, I took the fourths and cut thirds, and I took the thirds and cut fourths. So we're doing a kind of cross multiplication up here on that. We took the idea of having thirds over to those 3 stripes I had here. 3 times 3 is 9. We took the idea of fourths over here, and those 2 stripes got multiplied by 4 to give us an 8. And then both of them got that 4 by 3 action going on for 12. And so here's my 9 pieces over here and my 8 pieces over here. So after we play with kids by cutting up fractions like each other to have a common denominator, that gives us to this idea of this kind of cross multiplication idea for comparison. And it turns out this particular action right here, this cross multiplying that's happening, is helpful for comparison. But it'll also be helpful when we get around to figuring out why we have to add the way we do, why we have to subtract the way we do. Multiplication and division are pretty different, so they don't directly relate to this. But again, it's going to help us out with addition and subtraction. So let's look at a couple more examples of this.